let's talk some forces. Two lifeguards pull on ropes attached to a raft. They pull in the same direction. The raft experiences a net force of 334 newtons. If there's a net force, one thing that you know is that that thing is going to what? It's going to accelerate in a way proportional to its mass, to the right. If they pull in opposite directions, the raft experiences a net force of 106 newtons to the left. Draw a free body diagram representing the raft for each situation. So first I'm going to do the raft when they're pulling in opposite directions. Okay, or no, same direction. Two people pulling. I'll call force applied from the first person, and force applied from the second person. Now let's look at the other possibility. Okay, this way they all pull 300. The total is 334 newtons to the right. In the other scenario, same raft. One person's pulling to the left, the other person's pulling to the right. Here's a question: who's pulling harder? Pulling harder to the left or harder to the right? Net force is 106 to the left. So what that means is the person pulling to the left is pulling harder than the person pulling to the right. So that's the applied from one person. This is the applied force of the second person. Two situations. Now here's the fun question. Find the force exerted by each lifeguard on the raft in the situation. And that question, if you look at these two things, you're like, well, how could I possibly know that? You're going to do something that in Algebra 2 was called a system of equations. And actually, you may have also done this in Algebra 1. But let's write a couple equations. The applied force of one person plus the applied force of the second person is equal to 334. And then what else do we know? We know that, and these are both pulling to the right. So I have established now that the right direction is positive. So the other side, this applied force 2 is the positive force minus applied force 1 is equal to what? Remember, the left direction is negative, so negative 106. Now we have two equations. They have two unknowns in them, and so we can solve for both of them. Solving for them can be done in multiple ways. It can be done with elimination, substitution, even graphing. But I'm going to do substitution because I feel like that's maybe what most people would try. So the first thing I'm going to do is move A1 to the other side. So plus the force by the first person on both sides cancels out on the left, and on the right we have a positive force applied by the first person minus 106. And so what do? Plug it in, plug it in. Force A2. Okay, the problem here is that we have two separate forces. We can't solve for both of them. Well, force A2 is, that's what the equal sign means, force A1 minus 106. It's 106 less than the applied force of the first person. So we can substitute that and plug it in right there. FA1 plus this, FA1 minus 106 is equal to 334. What's force applied 1 plus force applied 1? That's 2 force applied 1s. Minus 106 equals 334. Add 106 to both sides. 2 force 1s is equal to 440. Which means that the applied force of one person is equal to 220 newtons. And what is the applied force of the other person? It's just 220 minus 106, which is 114. All right, we won't do a ton of those, but you can solve for two things if you have two scenarios and you know enough about them, only two unknown things. All right, while we're here, yeah, we're going to stop there, and we'll pick up the other one in another video.